you ever noticed how your fingers look like wrinkly old raisins after a long bath? It's a classic moment. Maybe you've wondered if you're secretly turning 90 years old. But don't worry, there's a fascinating science reason behind it. Today we're diving into why this happens, and I promise once you understand it, you'll never forget. Get ready for a quick, fun journey into the world of osmosis, the process that makes your skin wrinkle in water. Let's unravel this everyday mystery together and see how something as simple as water can change the way we look, literally. But what's really going on with your fingers? The answer is osmosis. Osmosis is a special kind of movement that only involves water molecules. Imagine water as a crowd at a concert, always moving from where there's a lot of people to where there's more space. In your skin, water moves through tiny gates in your cells called membranes. These gates are picky. They let water in and out, but not just anything. This movement is what causes your skin to wrinkle after soaking in water for a while. Let's break down how this works and why it matters. Picture your cell membrane as a nightclub bouncer. It's not letting just anyone in, only water molecules get the VIP pass. Salt, sugar, and other substances. Sorry, not on the list. This selectivity is what makes osmosis possible. The cell membrane is called selectively permeable because it chooses what can pass through. When you're in water, the balance of water inside and outside your skin changes, and the bouncer starts letting water move in or out to keep things fair. This is the secret behind those prunty fingers. Water is always trying to make things fair. If one side of a membrane is super salty and the other side is watery, water moves toward the salty side. It's like water wants everyone to have an equal share. This balancing act is what keeps your cells healthy and functioning. When you soak in a bath, the water outside your skin is different from the water inside your skin cells, so water starts moving to balance things out. That's osmosis in action, working quietly behind the scene. See osmosis in real life. If you drop a raisin into a glass of water, something amazing happens. The raisin swells up. Why? Water sneaks into the raisin through its tiny cell membranes, making it plump and juicy again. This is osmosis at work, water moving from where there's plenty, the glass, to where there's less inside the raisin. The same process happens in your skin, just on a smaller scale. Isn't science cool? Here's a sticky phrase to help you remember. Water moves from plenty to needy through a picky gate. It's catchy, right? Whenever you think about osmosis, just recall this phrase. Water always moves from where there's more to where there's less, but only if there's a special gate, the selectively permeable membrane. This simple idea is the foundation of so many cool science facts, from wrinkly fingers to plump raisins. Let's clear up a common confusion. Osmosis is about water only. No salt, no sugar, just water molecules making their move. This is what makes osmosis different from other processes like diffusion. So next time you see your fingers wrinkling or a raisin swelling, remember, it's all about water finding balance and nothing else. For osmosis to happen, you need a partially permeable membrane, a picky gate that lets water through but blocks other stuff. Think of it as a filter that only allows certain things to pass. This is why osmosis is so special and important in biology. Without this gate, water couldn't move in the way it does and cells wouldn't function properly. Let's make it unforgettable. Water plus plenty to needy plus picky gate equals osmosis. Imagine writing this on a sticky note and putting it on your brain's fridge. This formula sums up everything you need to know about osmosis in one simple line. Whenever you're stuck, just remember this sticky note and you'll ace any question about osmosis. Let's recap. Osmosis is the movement of water from where there's more to where there's less through a selectively permeable membrane. That's it. This one line captures the heart of the process. Whether you're thinking about wrinkly fingers, raisins, or even plant cells, this rule always applies. Keep it in mind and you'll always have the answer ready. Ready for a hands-on experiment? Here's your mini science dare. Take 2 potato strips. Put one in plain water and the other in super salty water. Wait 20 minutes. You'll notice a big difference. One strip becomes stiff and strong while the other goes weak and floppy. This is osmosis in action, and you can see it with your own eyes. Try it at home and see what happens. Here's a question for you. Which potato strip goes floppy and why? Think about what you've learned about osmosis. When a potato is placed in salty water, water leaves the potato cells to balance the saltiness outside. This loss of water makes the potato strip floppy. In plain water, water enters the cells, making the strip stiff. Can you explain it in one sentence using the word osmosis? Osmosis isn't just about science class, it's happening all around us. From your wrinkly fingers in the bath to how plants absorb water from the soil, osmosis is everywhere. It's a process that keeps living things balanced and healthy. Next time you see something swell or shrink in water, you'll know exactly what's going on. Osmosis is your new science superpower. Understanding osmosis helps us appreciate how our bodies and the world work. It explains not just wrinkly fingers, but also how our cells stay healthy, how plants grow, and even how food is preserved. Science isn't just about memorizing facts, it's about seeing the connections in everyday life. Osmosis is a perfect example of that. Now it's your turn. Try the potato experiment. Watch your fingers in the bath or drop a raisin in water. Notice how water moves and changes things. Share what you discover with friends or family and see if you can explain osmosis in your own words. Remember, water moves from plenty to needy through a picky gate. You're now an osmosis master.